Ever wonder how AI actually figures out what to do, like how robots on Mars knows what to look for, or how ChatGPT knows where to dig up the right answer, or even more fundamental, how AI learns to think and make decisions in the first place? Well, it's all tied to the massive, messy world of big data and how we manage it, label it, or make sense of it. Today I'm breaking that down, starting with two of the most important fundamentals in AI, supervised learning and unsupervised learning. And I'll give you a quick tour of other learning types so you actually get what's going on inside an AI's mind. By the end, you will know the stuff most other videos skip.
Oh my God, I can't believe it!
Alright, let's start with a fun example. Picture this, I just bought an insane Lord of the Ring Lego set, you know, the kind that costs way too much but you convince yourself it's an investment.
One ring to rule them all.
One ring to find them.
Oh, Jesus.
Inside, I've got all pieces and the nice shiny instruction book and some Lego expert standing right there saying that, yep, that's a hobbit head, that's a sword, that's a tower piece. That's supervised learning. I've got the pieces, that's my data. I've got the labels, instruction book, and I know exactly what I'm building Mina Street. So I'm basically following examples until I can do it on my own. I had my friend with me, poor guy buys the same set, but the box has no instruction, no labels, no nothing, just a mountain of bricks and the weak sense it's supposed to be a castle. That's unsupervised learning. No one tells you what's what. You just start grouping stuff like, okay, all these round gray pieces looks like a tower, or these green ones are probably grass. You're just hoping the picture in your head is something close to the final map, Mina Street Castle. In machine learning, both approaches can get you something really cool, but one's a smooth ride.
Smooth! Very smooth stuff, very classy.
And the other one is, well, I guess an adventure.
I'm going on an adventure!
Supervised learning is when you've got the data and the correct answers, the labels. You train a model with examples where already known the output so it can learn to picture future outputs. Like in spam emails example, if you want to make automated spam filter, you feed in labeled emails, spam or not spam, and the model learns the patterns so it can classify new emails. In other words, you know the end goal before you start, and you're teaching the model exactly what that goal looks like. Unsupervised learning is when you've got data but no labels. The model's job is to find hidden patterns, group things together, or spot anomalies. Imagine you're running a retail chain with thousands of customer receipts, clustering people based on what they tend to buy together and revealing patterns you wouldn't have spotted on your own. You don't tell the model what to look for, it discovers the natural grouping for you. For instance, the data might uncover that customers who buy dog food often also buy vacuum bags in the same month. At first, those products look totally unrelated, but the connection makes sense once you realize dog owners need to clean up more pet hair, right? It's all about discovery and no right answers given ahead of time. I have a question in my mind saying that, why do we even use these? So let's zoom out a bit. Why are supervised and unsupervised learnings such a big deal in machine learning? Because at the core of AI, we are always chasing prediction and pattern discovery. Sorry, my husband is making lunch. There might be some noises. Anyways, I was saying that because at the core of AI, we are always chasing prediction and pattern discovery. Without these, AI wouldn't be intelligent. It would just be a glorified calculator. We would be stuck doing everything manually, slow, error-prone, and impossible to scale. Before we go too deep, let's take a quick tour of the 7 main types of machine learning, just so you know where supervised and unsupervised fit in the bigger picture. This is when you already have labeled data and you're basically trying the model to predict or classify something. Second, we have unsupervised learning. This is again when you have no labels and the model's job is to find hidden patterns or spot anomalies. Third is semi-supervised learning. This one's the middle ground. You got a little bit of labeled data and a whole lot of unlabeled. The small label portion helps guide the rest, which saves tons of manual work. Here, the model actually generates its own labeled out of raw data. That's how systems like large language models, including ChatGPT, get trained predicting the missing parts of data to learn structure without needing human to label billions of examples. Then we have reinforcement learning. Instead of labels, this one uses rewards and penalties. The model tries something, gets feedback, and learns from trial and error, exactly like training a dog or to play chess better than human. Another one is transfer learning. Here you started with a big pre-trained model, something trained on a massive amount of general data, and then fine-tune it for your smaller specific task, like using a giant model trained on millions of images, then adapting it to recognize medical x-rays. And finally, we have active learning. This is when the model is smart enough to ask for help. It specifically requests humans to label only the most useful or confusing examples, making training way more efficient. So we can say supervised and unsupervised are two pillars, but these others are extensions and creative blends that make AI smarter, faster, and more practical in the real world. I'll break down the other 5 in more detail next time. For now, I think this covers the essentials.
Cool. Awesome. Cool.
Now I have this question in my mind. How does unsupervised figure out? If unsupervised has no labels, how does it actually figures out which is which? How does it know what's noise or what's anomaly? It doesn't know in a right or wrong sense. It recognizes data by math, similarity, density, structure, and distance. Another question is that if our unsupervised model starts out with no labels, how do we actually turn its output into something meaningful in the real world? This is where the model does its job and clusters the data. Then a human expert steps in to inspect those clusters. They look at what's in each group, recognize the patterns, and give them names. For example, in astronomy, you might have a model clustering galaxies based on their features, and then an astronomer comes along and labels those clusters as spiral galaxies, elliptical, or quasars. Once those labels are assigned, you can now use them to train a supervised model that can recognize those categories. Second, the semi-supervised. Here we take a small set of data that are labeled and feed them into the model alongside the unlabeled data. These labeled examples act like anchors, guiding the model in how it should treat the rest of the data. The labels spread through the dataset, giving the model a much better sense of a structure without us having to manually label everything. Third one is external validation. Sometimes we can compare the model output against an entirely separated trusted dataset. Imagine a bank running anomaly detection on transactions. The unsupervised model flags anything that looks unusual, and later fraud investigations confirm which of those were actually fraud cases. Those confirmations are then fed back into the system so that a supervised model can be trained for direct fraud prediction. And finally, we have iterative reinforcement. This is where we tweak the model's clustering parameters using our own domain knowledge. Run it again, check the results, and repeat until the patterns it's producing make sense. It's still unsupervised at its core, but we are steering it in the direction through guided trial and error. Now, how algorithms define noise and anomaly. Here is something important to understand. In unsupervised learning, noise and anomaly are not universal concepts. They are defined entirely by the algorithm you use. DBSCAN, for example, it's a density-based clustering algorithm. It looks for regions in the data where points are packed closely together. Anything that's too far away from these dense regions gets labeled as noise. Or isolation forest. It works by randomly splitting the data into trees. Points that get isolated very quickly in this process are considered anomalies.
Stay with me.
Then we have one class SVM, which tries to learn the boundary of what normal looks like in your dataset. Anything that falls outside of the learned boundary is flagged as an anomaly. And finally, LOF, local outlier factor, works by asking a really clever question. How dense is the neighborhood around this point compared to the neighborhoods around its neighbors? If it's much lower, it's marked as an outlier. And this is why these anomaly detectors are so important in unsupervised learning.
Where are you getting this information?
Because in unsupervised learning, there are no labels, no teacher, no right answer given to the machine. Without algorithms like these, the model has no way to even suspect that something is odd. It would just treat every data point as equally valid.
Okay, we're fine. Everything is fine. It's all good.
Noise detection is basically the machine's gut instinct. It's the first step towards saying, hey, these don't fit the pattern. Maybe they deserve a closer look. And from there, humans or supervised models can step in to confirm what's really happening. Without this step, unsupervised learning would be like wandering through a crowded city but never noticing the pickpocket, so you'd miss the anomalies that actually matters. Now let's go through an example which shows you what's the process from unsupervised learning to supervised learning. Let's tie this all together with a real-world example. So we want to detect banking fraud. The first step is that we start with an unsupervised model that learns what normal transaction patterns look like from millions of past transactions. Step 2 is it begins flagging any transactions that don't match these normal patterns. Maybe they are unusually large, happen in a strange location, or occur at odd times. Step 3 is the bank's fraud investigation team reviewing these flagged transactions manually. After that, we have a step 4. The confirmed fraud cases from that review are labeled and added to the dataset. In step 5, now that we have labeled data, we can train a supervised fraud classifier. At step 6, the supervised model takes over predicting fraud detection without waiting for manual review. This is a common pipeline. Start with unsupervised learning to explore and detect anomalies, then shift to supervised learning to lock in accuracy and scale it up. If you watched my past videos, you would know that I've talked about heuristic algorithm and meta-heuristic algorithm. So there's a question here, where heuristic and meta-heuristic algorithms fit in this concept? Like, can we use both of them in supervised and unsupervised learning? Absolutely.
Oh, wow.
So in supervised learning, these algorithms are often used to fine-tune hyperparameters, choose the best feature, or even design the architecture of the model. For example, you might use particle swarm optimization to tune the parameters of decision tree that's classifying customer loss. Here, the key idea is that supervised or unsupervised learning tells you what type of teacher the model has, but heuristic and meta-heuristic optimization algorithms determine how the model itself searches for its best answer. Now I'm like, where should I pick supervised, when should I go with unsupervised, and when should I mix them together? If you've got labeled data and you know exactly what you want to predict, supervised learning is your best friend. If you've got a huge dataset but no label, you start with unsupervised. If you've got a mix, some labeled, some unlabeled, you're in semi-supervised or self-supervised priority. Unsupervised learning is the explorer, like the Mars rover mapping the unknown landscape without a guide, or you poking around a new dataset to find hidden patterns. Supervised learning, on the other side, is the expert itself, like ChatGPT fine-tuning its answer once it already knows what good looks like, or navigation systems taking the fastest route to a destination it's already mapped. Now, when you think about those big questions from the start, how does a robot on Mars figure out what to look for? How does ChatGPT know where to find the right words for your answer? Or how do AI systems learn to think, decide, and act? You've got the core mental model.
You're goddamn right.
And you also know that in the vast world of big data, these two aren't rivals, they are actually partners. So let's say by now you not only know what supervised and unsupervised learnings are, but also you know that why they are the foundation of AI and how all the other learning types fit into bigger picture. We'll see you in the other video. Bye!